Okay, so if you want to run a local AI model on your computer, then you need to spare a few gigabytes of your memory or perhaps your video memory because it is faster on your device, so you can load the model weights onto your computer and you can run it, and then you can chat with AI, doing lots of cool stuff like perhaps regular chatting, summarizing documents, or maybe doing some agentic tasks. But right now, the biggest problem is the fact that the model is usually very big. For example, if I want to run the Llama 4 model with 31 billion parameters at full precision, the size is, I believe, 65 gigabytes. So it's really big, and that means I need 65 gigabytes of video memory just to be able to load the model into my system, and I don't have a computer with that amount of VRAM. So for most people, you might want to compress the model. You want to use the version that has been optimized or compressed into a certain size, and usually the 4-bit quantization or 4-bit compression like Q4KM, like this example, is the best bet for most people. Though you can always choose something that is a bit bigger or smaller depending on your use case. But even at 4-bit quantization, the model still demands near 20 gigabytes of video memory, and that is just for loading the model. That is not even considering the context length, the amount of extra tokens that it needs to remember during the chat. So I need maybe 24 gigabytes minimum, or ideally 32 gigabytes, so I can run this model. So for me, I cannot run this model comfortably, at least not at the full speed. So I'm stuck with a much smaller models that can fit nicely into my video memory. But there is a new technology, there is a new way to make AI to be a lot smaller, and I'm talking about 14 times smaller than the original size. So at 4-bit quantization, usually it's going to be about 4 times smaller, but I'm talking about something that is 14 times smaller. So enter 1-bit model. So this is the first commercially viable 1-bit large language model. So just to clarify, this is not actually a compression. In fact, the model has to be trained at this exact precision. So it is not like a big model that now can be compressed into a small model. So it has to be a model that is trained from ground up at this level of precision. So the name of the model is Bonsai, and it is from a startup called PrismML, and they do have 3 variations or sizes. There is the 8 billion parameter model, there is also the 4 billion and 1.7 billion parameters model. So because of that size, the model has a very high intelligence density, not even close. It's actually way higher, and the second place is not even close to reach the level of this model. So that is just insane. And even with a much smaller size, this 8 billion parameters model is actually quite on par to other models in that area, in that size. Like it is beating models from LFM, from Llama, JLM. It is also on par with Mistral and even Quen 3. So if you look at this table, you can see that the other models are 14, 16, 18 gigabytes, but Bonsai is only 1 gigabytes, and yet it is quite similar to other models that are basically 15, 16 times the size of this model, which is just really insane. So it is still very new, and I'm not going to go into much detail about the technology behind it, but you can check the video from ByCloud that explain this LM in great details. I'm going to put the video link in the description down below. But now, basically what you need to know is that you can start chatting or using this model on your computer. So they have some benchmark number, like they are able to run the model on M4 Pro Mac, and it runs at 130 tokens per second. And if you're running it using RTX 4090, you can expect 360 plus tokens per second, and it can even run on an iPhone and can produce 44 tokens per second. So that is not a number that you can usually expect when running a somewhat a decent or big model, which is 8 billion parameters on a small device like an iPhone. Usually you'll get only like 10 or 20 tokens per second, but now we can get this very large number. Now the model now has the version that is compatible with Llama C++, which is the engine behind LM Studio. So you can start using the model on your computer, and you will be very surprised on how efficient the model really is. So to use the model, I do recommend to use LM Studio, and this is just the easiest path for most people to start running a local AI model. It has this nice user interface, and also it has a very large community behind it. So I think when there is a new model release, you can expect that that model is available or in the format that can run in LM Studio. Now, to download this 1-bit model, you can navigate to model search, and then you can type Bonsai. And as you can see here, we got plenty of options, but let's focus on the ones from PrismML, which is again the lab behind this model. So there's Bonsai 8 billion, and then 1.7 billion and 4 billion parameters. So I think you can start with 8 billion parameters. After all, it is only 1 gigabyte. So if you have a computer with only 2 gigabytes of video memory, you can run it just fine, no problem. In fact, maybe you can get away with 1 gigabytes of video memory. But either way, it is a very small model that you can run on pretty much any computer that was produced in the last 15 years or so. So I think the memory issue is no longer a problem here. And by the way, there is also another version called ternary Bonsai, and this one is not 1-bit, this is actually 2-bit, so it is bigger. It is actually double the size than the 1-bit model. So if you want to get a bit more precision, a bit more accuracy or quality, then you can go with this. But I think you can start with something simple just to experience the 1-bit large language model on your device. So you can download it, and then you can start chatting with the model. Now I'm going to set the context length to a maximum, and then I'm going to just keep everything the same. I'm not going to change any settings other than the context length. Load the model, and yeah, I think it's running. Now, let's say I want to ask something like, can you give me the summary of the moon landing history in 1 paragraph? All right. Okay, so I think it is pretty accurate. I'm not going to double check everything, but I think that's pretty accurate, and I'm getting 80 tokens per second. So that is actually a bit slower than my previous testing. Usually I can get something like 100 plus, but perhaps because, oh, there you go, I'm running this while recording this video. That's why some of my computational power is actually being used for other things. But as you can see, it is still able to reach 100 plus tokens per second. And by the way, I'm using RTX 5060 Ti, 16 gigabytes, and that has plenty of room to maximize the context length. And yeah, running a model like this is not a problem. Now let me try something else. I'm going to upload a document. So this document is basically about SpaceX IPO. That's his article about SpaceX IPO. So I'm going to ask AI if it can summarize it. Please summarize this document in 5 bullet points. Okay, it's really fast for an 8 billion parameters model. It's really fast. Okay, so 1.7 trillion and 2 trillions. Yeah, that's actually the number that they are predicting. And I would say it's pretty accurate based on the document. So it is able to summarize content from the document that you might have provided. Now, if you look closely when you are actually doing a model search on LM Studio, you might have noticed that there is no tool calling capability. So there is no hammer icon. Usually in some new models, even the smaller ones, they do have this tiny icon, the hammer icon, meaning that the model was trained for tool calling. It can use tools that can be used for perhaps doing some agentic tasks, like maybe doing a web search or managing documents, organizing files, etc. So there are many use cases when the model was trained for tool calling, and that's why it has becoming a standard for a new model, open source models, to come with this feature. But on Bonsai, I don't see that icon. However, I think it is just simply because it's not supported in LM Studio, or at least the model is not exactly the best at tool calling. So it was the model architecture was actually from Qwen model, and Qwen has tool calling. So I think it has the elements to actually use the tools. Now, I actually have tried that on anything LM, so it has a more robust environment for tool calling. So let me try something else. Let me try ask AI to, okay, let me just show you that I'm using the Bonsai model from LM Studio. Okay, Bonsai here, 8 billion parameters. Okay, so let's say, can you tell me the AI news today? Let's see if we can get some answer. Okay, it tried to use the tool, but it wasn't able to get the answer. At least it is able to try, at least try calling the tool. Let me try it again, maybe using a more direct phrasing, like please do a web search and tell me about the AI news today. Okay, so yeah, I guess it is not very consistent, but there is actually a video of the guy who made anything LM, and he tried to use this model on anything LM, and it was actually able to use the tool to conduct a research on the web and get a more accurate answer. So perhaps it's just something on my settings that might prevent the model to actually use the tools. And also, I'm not really surprised about this, because it is not the primary goal of this model is really to just demonstrate that 1-bit LM can exist and it can be used, although for tool calling it is probably not the most reliable. So the current use cases, if you really want to use the model, is perhaps for simple chatting or summarizing documents, and even that I do recommend to not use it as a tool, as a model for tool calling. And also you don't want to rely on the answer all the times, because at this level of precision, I think it can hallucinate quite a bit. So yeah, those are a few warnings that you need to know if you really want to use the 1-bit model on your computer. But regardless, this is definitely a very welcoming advancements in the AI technology. So I'm hoping that in the future we can use local models. We don't have to worry about video memory or system memory to run a decent model. So imagine maybe in the future that we can have models that were trained from ground up to actually capable to run in this level of precision. Like imagine if GPT 120 billion parameters can run at this level of precision, and that means it will only require 15 gigabytes of video memory, and that is the level that most consumers can afford. So yeah, it's a very interesting demo, and let's see how it will advance in the future. So basically all the links that I use in this video will be available in the description down below in case you want to check them out. So thanks for watching, and I'll see you on my future videos. Have a great day.